So that's recording, isn't
It
it?
is recording. All right, first question says, let negative 3, 4 be on the terminal side of theta. Find sine, cosine, and tangent of theta. So when we have an ordered pair, and we're talking about being on the terminal side, maybe where's a good place to start?
X. Wait, what do you mean?
We got to find sine, cosine, tangent. Where would be a good place of starting? They've given us an ordered pair.
Graph it.
Let's graph it. Let's graph it. Yeah, we'll do it. So negative 3, 4. Negative 3, 4. So we're graphed it. But then from here, we're going to make our triangle.
It is.
So then you go down to the x-axis.
So then we go straight to the x-axis from this point. We go straight down, make a 90 degrees,
So wait, is
and
that
there's our
line-
triangle.
Is the line going straight up the terminal side?
That one up there.
What's the terminal?
That one's the start.
Oh, that's
So we like rotated it around.
Okay.
Yeah. So I'm just gonna draw my triangle bigger so you can see it from way back in the back. And if I'm starting at 0, 0, and I'm going left 3, this one is negative 3, then I'm going up 4, this one's positive 4. My theta is between the terminal side and the x-axis. And then we have to find sine, cosine, and tangent. So this is repeating what we did last class. Sine of theta is not opposite over hypotenuse from last class. From last class it was y over r. And how do we know r is 5? It's a triple 3, 4, 5, or we do the Pythagorean theorem and find that it is 5.
Wait, I thought we just said sine was y.
It is y over r.
Or
It is, oh, you're saying just y?
Oh, because the radius is always y.
Right, right. For the
Oh, so now
unit
it's
circle, this is not the unit circle.
Okay.
So we're going to put, what, 4 over 5?
just
All right, then we're going to do cosine. Cosine, what's the formula for cosine?
x over y.
Over r. And that is negative 3/5. And then tangent is
Y over x.
y over x. So that would be negative 4/3. Notice how I pulled that negative and I put it in front, not on the bottom. And then it,
Do extra stuff.
good. The next example, I'm going to pause the video and you're going to do some thinking and start drawing to figure it out. So this says given tangent of theta is equal to negative 5 over 4. So we already know what the tangent is. We also know that cosine is greater than 0. We have to find the sine of theta and the secant of theta. So as we're thinking, all right, I know tangent is what over what?
Y over
Y.
Y over X.
Y over x. So we know tangent is y over x. And we know cosine is x over r or just x. But regardless, it's x. And what is this telling me? Cosine is greater than 0. What's it telling me about x?
It's not in the fourth quadrant.
It's not the negative.
It's telling me that x is not negative.
Right.
So that's going to help me locate where this is going to be.
So should we draw out this triangle?
Yes, so I'm pausing it. You draw out the triangle.
Because that's our ordered pair right there.
So 4 negative 5.
So we thought about this. We said, all right, cosine is x, and x has to be positive. So it's either in the first or the first or the fourth quadrant. Those are the only places that x is positive. And x has to be 4 because x has to be positive, meaning y is negative 5. So we're going to go 4, negative 5. And then we're going to draw that triangle that goes over 4, down 5. Some of us had our triangles kind of in the wrong spot, but like in the right quadrant, but the wrong spot. Yeah. So cosine is greater than 0, which is x. So I'm looking at these two numbers, y over x. X has to be positive. So there's only one negative sign, it's got to go with the 1. So then I go on my graph, I go 4 on the x, and I go down 5 on the y. Now to find sine, I know this is not the unit circle because my hypotenuse is going to be longer than my sides. So this is not the unit circle. I better find, by using Pythagorean theorem, I better find the radius. So square root of 16 plus 25, 41, which is the square root of 41. That doesn't simplify, square root of 41.
Can I check someone?
So our sine is going to be, y is -5, and then we would divide that by square root of 41, but I'm thinking ahead. Since I'm dividing by the radical, I'm going to rationalize it.
-5 square root of 41 over 41.
Okay? Then we're going to do our secant. And our secant is which one flipped? Cosine. So cosine is normally x over r. This is going to be r over x. So we've got square root of 41 over 4. Okay, questions before we're going? Example 3. Now in your assignment, they're going to give, you're going to have this whole section that is asking you to find different functions, not just sine, but different functions on these quadrant angles. Anytime you're going to use the quadrant angles, I would just go ahead and find those points.
Start recording.
Hmm?
Did you start recording?
I did.
I'm sorry.
Hopefully. Okay, so this point right here is 1, 0, and then we've got 0, 1, and then we have -1, 0, and 0, -1. So I have all the quadrant ordered pairs for the unit circle, and then we have to find sine at each of those. In your assignment, they're going to ask you more than just sine. They might ask you tangent or cotangent or secant, anything. In our example, it's just sine. So we're going to do sine of 0 degrees. So go to 0, and what's the formula for sine? It's y over r, but what's my radius for this?
1.
The radius is already 1. So 1 over 1 is, just kidding, that's not.
That's 0.
0 over 1.
So wait, 0.
So it's,
Oh,
Question.
Never mind, I got it.
Okay. I'm just writing the other ones down. Okay, so the next one, sine at pi over 2. So that's going to be the one on the top. Sine at pi over 2, what's y? 1. Sine at pi, what's y? 0. Sine at 3 pi over 2, what's y? -1.
that's simple.
Yeah. Bonus, not in your notes. Let's do tangent of, I don't know, pi. How do we do tangent? What's the formula for tangent?
Y over x. So this is
0 over
pi.
-1, so 0.
Okay. What if you asked to find cotangent?
I'm the sine.
Yep. Opposite.
So there's a section in your assignment that just asks you to do, you just draw that picture once and you print all the information. If I do go too fast, remember my notes will be on Canvas, the video will be on Canvas, if it works. Reference angle, we talked about that last class. Just remember, reference angle has to be positive and it has to be acute, meaning it's between 0 and 90. It has to be positive. So if you're going in the negative direction, the reference angle you still call a positive number. It also connects to the x-axis. So for 300 degrees, we have to find the reference angle. So for 300 degrees, I'm going to first go around to 300 degrees. About there. There's 300 degrees.
So the reference angle is 60 degrees.
And then we go straight up to the x-axis. My reference angle is located right there. And yeah, that would be 60 degrees. How'd you get that?
Well, so go to the next
60 left to get the.
So you, in your head, did 360 minus 300. That's what you did in your head. And I'm going over that because they're not always so easy. So I'm now going to pause it. And B, you should be able to get. C, I want to see who can get. So we'll see. I got prizes if you can get it. Oh. Is it working?
Yeah.
Yeah, that's not that.
Yeah.
So it's
Coming
going,
up.
but
I think it's working. Oh, there it is. There it is. So for this one, we had negative 135 degrees. That was like to here. And then we draw to the x-axis what's left over. 45 degrees. Good. Okay, for this one, 2.3. Remember we had that picture where we had it just in radians rather than radians that have the pi symbol in it. And you guys know from here to here is how many radians? Pi radians, right? So, which is approximately 3.14. So if we're going 2.3 radians, we're going about here, and then we drop straight down, and our theta is what's left over. So we take 3.14 minus 2.3 and get approximately 0.84 radians. You just take the full amount and you subtract out the piece you have. It's just our full amount is 3.14 rather than 180 degrees. That was the only difference. We have to be training our brains to know radians instead of always converting. If you always convert, your homework assignments eventually are going to take you like 4 times as long. And we have got to be efficient. So we've got to start thinking in radians. This next section, these are just notes. The first one I feel I would use somewhat often. The second one I don't use as much, but I'll go over both of them here. This is, yep. This is telling us which ones are positive and which ones are negative. And that all students thing, I'll tell you, I'll write it up here. That only has to do with the 3 main ones. If you're memorizing that.
This is called
All students.
That's just a saying that somebody has made up to help you remember which ones are positive in which quadrant. So in quadrant 1, all of them are positive. And then in quadrant 2, S is positive, so sine. So we're just going off the main ones, sine. And then in quadrant 3, T, tangent, is positive. And then in quadrant 4, for C, it's cosine. You're just going off the main ones, not cotangent, just cosine. So if you can remember, all students take calculus, then you know which ones are positive. You've memorized which ones are positive in which quadrant. And then for the second one, this just has to do with how you can find the reference angle. Depending on which quadrant it is in, there's formulas for you. You don't have to use these formulas. I don't use them. I just like think about it. I look at the picture and I think about it, but you can use the formulas. They're there for you. I would not give you any of this stuff on a quiz or a test. So this is not something that would be provided. So if you are only using the formulas and not actually thinking about it, you will be in trouble when you have a quiz or test because you're not getting that. All right. Find a solution that make the statement true. Some of these are going to have more than one. And then we're going to give our answers in degrees and radians. So we're going to look at A, and it says cosine of theta equals negative square root of 3 over 2. We're trying to find a solution. That means we're finding something that's not given. There's only one thing up here that is not given. What is it? Where's the variable right here?
Theta.
Theta. And what's theta stand for? Not the reference angle, but it actually stands for the angle.
Oh.
So it could be the reference angle, but it could also be that original terminal side theta,
And then
which
we
is
have to
what we're doing. And then from there, you'd make a reference angle and you'd find all this stuff. So we have to figure out what degrees and what radians would give us cosine of theta negative square root of 3 over 2.
So is this thinking back to like 30, 60, 90?
So do you think,
Because those ones are
yeah,
30, 60, 90.
remember that chart we filled out last class that had all of the 30, 60, 90 and the 0 degrees and 90 degrees, 45, 45, 90, and how all that stuff, the stuff that you're supposed to be starting to memorize. If you don't have that memorized yet, you might want to have it handy. Because we need to figure out when cosine has a square root of 3 over 2 and when cosine is negative. We need to figure out both of those.
Okay.
So I'm going to start by drawing a picture because I'm a visual person. I draw a picture. And I'm thinking, where is cosine negative? Or where is cosine not positive?
All students take
All students take calculus. Cosine is positive in all in the C.
So it's negative in
2 and 3.
So I know that this is either going to be in 2 or 3.
Can't you have two answers?
There will be 2 answers. Yes. The next thing I got to figure out is what degrees gives me cosine square root of 3 over 2.
So,
And so I either have my brain and I'm thinking because I'm memorizing it, or I'm looking at my chart until I have it memorized.
cosine of 30.
Okay, so you guys are looking at the chart, but I know, I've already memorized. Sine of 30 is 1/2. So then I know cosine of 30's got to be the other one.
Right.
So I do know it's 30 degrees. Where can we find a 30-degree reference angle in the second
140 degrees.
at 150 degrees? That would be in the second quadrant. A 30-degree reference angle. Trying to put my 30 in there, it's kind of small. 30 degrees right there. But there is a second answer. Where could there be a 30-degree reference angle in the third quadrant? So there would be a 30 degrees right here, which if I started, went all the way around, yeah, 210 degrees.
Wouldn't it be 180?
Would it be what? Oh, okay. Now, when I convert to radians, I'm not multiplying by pi divided by 180. I'm going to do it by hand. I'm going to do it using fractions. And I would encourage you to start practicing this way. Okay. I'm just gonna draw the radian one. Hey. I'm gonna draw the radian one over here so you can kind of see. This is already messy. I don't want to mess it up even more. I'm gonna just draw it again and talk about radians here.
Oh, wait,
So I'm gonna start with the 30 degrees. How many 30s fit in that top half? There's 6 of them that fit in that top half. There's 6 of those. So I'm going to take pi, and I'm going to divide it by 6 to start. Each of those 30 degrees is a 6th of the pi. I want to start from 0 and move my way around through how many sections to get to
5 pi.
right. So there's 5 of those sections that gets me to that pi over 6.
which one are we on?
I'm just doing the radians for 150 degrees. This is this right here.
Oh, we have to convert it.
Right, but I'm not converting it by multiplying by pi divided by 180. I'm converting it by using a picture. because this is where we have to get our brains to go.
Okay. So can you just show that work? Because last time we just learned like.
If you know it, then use it. Not everybody has it memorized. I have it memorized.
210 would be.
Okay, so
7 pi,
210,
7 pi.
210 is down here, and it is still a 30 degree, so it's still dividing by 6, sections that divide by 6. We just have to figure out how many of them are there. So here's 6 of them, and then we've got one more, 7 pi over 6.
Okay. See that?
Would it be cheating this if we divide our the angle that we get by 180 and get everything?
Oh, you mean just straight up multiply by pi divided by 180, convert it.
No, like dividing 30 by 180.
You mean 180 divided by 30?
Yeah.
That's how I knew to put 6 here.
Oh, okay, so that's how you want to say that.
Right, until you have it memorized.
Okay.
Okay, I am going back up here and recording again.
Okay.
So for this one, cotangent theta equals 1, and we looked at our chart. We saw that tangent is 1 at 45 degrees. And where is tangent positive? First quadrant and third quadrant. So that's what my picture would look like. So if it's 45 degrees as one answer, the other answer is 225 degrees, right? And then for 45 degrees, we divide by 4s. And that's 1 pi over 4. And then all the way around here is 5 pi over 4. So we've got our 2 answers for that. Sine of theta. I was just saying this before I started recording again. I know that sine of 30 is a half. I have it memorized. So if this tells me sine of theta is square root of 3 over 2, I know it's not 30 degrees. It's got to be 60 degrees. So I'm going to go to 60 degrees. And then sine is positive in the first quadrant and the second quadrant. So we need another 60 degree here. So we've got 60 degrees and 120 degrees. So then we're thinking about 60 goes into 180 3 times. This has got to be 1 pi over 3. And then 120 would be 2 of those pi over 3. So that would be our radian. Then the last one, secant of theta is 1. So this is cosine flipped. So I know that cosine of theta has also got to be 1. So then I look at my chart.
I said 0.
It'd be positive 1, right? So the only place where cosine of theta is equal to 1 is right at 0 degrees. Or at 360, but that's the exact same place. So really just 0 degrees. Well, I mean, there's infinitely many. It could be at 360, it could be at 720, it could be negative 360, like just keep adding on 360. For all of these, there's infinitely many.
Right.
But some of these had triangles in 2 different quadrants. This one just has a quadrant angle at the ordered pair 1, 0. So 0 degrees, that would also be 0 radian. If you found it as 360, then it would be 2 pi radian, but it's the exact same place, same location. Doing good. We're doing well. Well, we're gonna have lunch in like 7 minutes, so we're not gonna play a game and go to lunch. I'm sorry. The next thing we're gonna do is just calculate. And calculate. So for these, we're gonna kind of do what we just did. We're gonna find 2 answers. We're gonna find 2 answers, just like we just did, except for this time it's using the calculator. With the other one, we were doing it by hand. So the first thing you wanna do is put your calculator in degree mode, please. Fine, there's no sinning in math, come on. Sinning, sin, sin, sign. Oh.
Did someone last year who kept sign, cost, and tan? Yes.
Okay, so first step we already know how to do. You already know that. You already know it. Second side, we find an angle. Type it in, make sure your angle is the same angle that I got. If your calculator's in the wrong mode and you're not practicing right now, and then later you're getting all the wrong answers, guess whose fault that is?
So what would this look like?
It's all Sarah's fault. All right, so 22.9, I'm going to draw that picture. There's a graph here. I'm going to draw the picture. And we have to find 2 answers. So this is, the sign is a positive number, where else? Second quadrant, right. Actually, I'm going to come back to that thought in a second. I forgot, we also have to do radians. And since we are using a calculator, you have 2 choices. You could go now, change your mode, and retype in everything, or just type in times by pi divided by 180 from your last answer. That's what I did. You don't have to do it my way. You can change the mode if you want, but I think that's extra work.
0.3.
Approximately, and this says to the nearest tenth in the directions it says tenth, so about 0.4 radians. Okay. But I don't really have to use 0.4 radians to graph it. I've already graphed it using 22.9. Now, the other place that it is 22.9, that the reference angle is 22.9, is in the second quadrant. That's the other place. But we have to find what terminal side angle put us there. So how would I find, I'm going to take 180, and then I'm going to subtract 22.9, and I'm going to get 157.1 degrees. That's how I know the other angle. When I go to do the radian version, I'm not going to convert it this time. I'm going to do the exact same thing that I did in red. I'm going to do that to the radian, but I'm just going to think in radians. So instead of 180 degrees,
3.1.
it's 3.14. And instead of subtracting 22.9, I'm going to subtract 0.4.
2 points.
And I get 2.74.
Yeah.
And then they ask us to round to the nearest tenth, so I guess 2.7. So you see how I'm just doing it in radians, the second part. The first part you definitely would want to convert. We're not thinking that in radians, but the second part you could just do in radians. Okay?
Okay.
So I'm going to pause the video, and we'll work till the bell rings, and we'll go back over it after lunch. For the second one, it's secant, but there is not a second secant button. So we need to think like cosine. So cosine is the reciprocal of this number.
So 1 divided
So I do 1 divided by negative 2.3412. So then we do second cosine, and then 1 divided by negative 2.3412. That's what you type in. Okay, so we started this right before lunch. We would type into our calculator second cosine 1 divided by negative 2.3412.
115.3.
115.3 degrees.
Beautiful.
And then we're going to go over here and we're going to find 115.3 degrees, about there. About there. And that is one place that cosine is negative, which it means secant is also negative. To find the radians, multiply by pi divided by 180. It's already on my calculator. I do it real fast.
No. What's that?
No.
Rick?
Approximately 2.
Oh, we're allowed to use that for this? Just the first one.
Just for the first one.
Okay.
I mean, you can use it for every single one, but I want you to start learning how to do radians. We're not going to learn if we aren't practicing. Okay, where is the other place that cosine or secant is negative?
The third.
Third quadrant. So the other one would be right there. And we've defined what angle goes all the way around to there.
Ooh.
How, and there is more than one right answer, how could I do that?
Would you have to
360 minus 150.
Okay, 360 minus 115.3 degrees would be one way of doing it.
Yeah, there you go.
That would
Yeah.
actually be the shorter way. There is another way where you could find the reference angle and then add the reference angle to 180. But I like efficiency.
Right.
So that is 244.7. And then I'm going to do the exact same thing that I did with degrees. I'm going to do it with radians now. So instead of 360, what am I going to do for radians? Yeah.
3.14.
Yeah.
Wait, say that again?
The first one we did 180.
You'd have to do 180 minus 115.3 and then add whatever you get.
Because that's just what.
Well, hold on. Were you asking about this one?
No.
What?
No, like why can't you do the 180?
Oh, for this in purple?
Yeah.
The location of this one, if I took 180 and subtracted 115, that would end up like over here. Be a small number. What that would actually give you is that would give you the reference angle, which is right here. And then you could take 180 and add on that same amount to give you that. That's more steps. Yeah, that is a way that works. That's just more steps. So there's more than one way of getting that second answer. I did it the shortest way.
Wait, that's just the answer number 2?
I'm not done with the
We have to
radians.
find the rad.
Oh yeah, we gotta find the rad.
Okay, so how do I make 360 degrees into radians?
6.28.
6.28. And then we're going to do the exact same thing. We're going to subtract out the angle we had before, so subtract 2.
Minus 2, and it's 4.28.
And then this says the nearest tenth, so 4.3.
4.3 rad. Oh, my helper.
All right, last one. Yeah.
Bingo. What's his name?
Oh.
So cotangent, there is not a second tangent button. So cotangent, there is a second tangent. There isn't a second cotangent button.
Yeah.
Sorry. Need to change it into tangent, so we're going to do 1 over 1.192. And then on our calculator, we'll do second tangent 1 divided by 1.192.
192.
Second. Yeah, I said that today in the hallway, and my good friend tried calling me. It's very nice.
So we convert that to radians by multiplying by pi divided by 180. Simply, really easy right there on our calculator. And we get about 0.7 radians.
He looks like
A woman.
So 40 degrees is about here. And this is tangent, so where else is tangent positive?
Austin.
Third. So we need to do what to get all the way around to here?
Third quarter?
Add 40 to 180. Thanks, guys.
Only I said it.
So we're gonna add 180 plus 40, we get 220 degrees for our second angle. And we're gonna do the same thing, but in radians. So instead of 180, we're gonna start with
Can't we just,
3.14, and we're gonna add 0.7,
oh, sweet.
and we get 3.84,
Plus 0.8.
which to the nearest tenth is 3.8.
Yeah.
3.8 rad.
Nearest 10.
Yeah.
My handwriting is rad.
My handwriting is right.
Practice.